Hello guys, welcome you all to the 10th session of Pandas. So in the last session, whatever we have discussed, we will continue our discussion from there. So as you know, there is a dependency of every session. So I have just copied these things from the last session, this alcohol series, and this is all. And this is a basically a data frame. So converted this data frame into uh, the data series. Fine. And I have run all these three cells. So I'm just copy and pasting it in my chat window so that you people can copy it directly and paste it in your cell and run it. So now let's see. Today we are going to start this something which is left in the last session. Then we will move to the descriptive statistics. So first understand this thing, dropping and filling any's. So what is this dropping and filling any's? So let's first access my alcohol series dataset. Alcohol dot, let's say, head. So what I'm getting this. So if let's say if you can see here, only in the head part, I have just accessed the first five um, values in the alcohol dataset. I can see there is a nan. Nan means null values is there. Similarly, if I will access all, and we know from our previous experience, the previous operations that we have performed on this alcohol series, we know that we have total 31 NN values or null values in this series, alcohol series data. And I want to drop it. I want to drop all my NaN values from my data set. For that, what I have to do? Let me first access this whole data. If you will see, there will be a lot of NaN values inside this data. And its length is 193. Can you see? Length is 193. So there is one method to drop all the null values or NaN values from this data set. And for that, what you have to write? You have to write alcohol dot drop, drop, drop Na. This is a drop Na. If you simply do this, and if you will run this, you will see that all the, now there will not be any NaN values inside this, the resulting data set. That resulting series, in the resulting series, there will be no NaN values. And now if you will see, previously the length of my data set was 193. And now the length is 162. What it means? There is a decrease of 31 length in the resulting data set because there were 31 NaN values. So that NaN values got dropped and now we are having 162 length. Length is having 162 because 31 NaN values get dropped. But if let's say, if I want to access this alcohol data set again, let's say I am accessing this alcohol series again. So what you will see, again, this NaN is coming. That means when we are doing this drop Na, at this time, I am getting the output. The output series doesn't have any NaN values, but the my base series, that is the alcohol series, there is no changes in my base series. That means there is no permanent changes in my original series. Whenever I am using this method, it is giving me the this series which is not having the NaN values. But when I am going back to my original series, nothing has been changed. Again, this NaN values is actually present in my original series. So there is no changes in my original series. But let's say if I want that, I want to change the original in fact, I want to make these changes inside this alcohol series data. So what to do in that case? So there are few methods to perform this. One way is called, there is a very simple way that we are using from the very day one, that is called, let me write it here. One way is called reassignment. One way is reassignment. With the help of this reassignment, I am able to, if I will, let's say, reassign this value, if I will write here, let's say if I will write like this, I'm not going to run, otherwise it will make the changes. Alcohol dot drop Na, and let's say if I will run this, I'm not going to run this right now. If I will run this, I will get the alcohol dot drop Na. This will get saved inside this alcohol variable. And now if I will access this alcohol variable, I will get this thing. That means the original alcohol get changed. This is called reassignment. So we can use the reassignment to make changes in the alcohol series. There's another way that is called drop Na method. So how, or you can, with the help of this drop Na method, how you will make the changes to the original data set. Let's say if you will like this, if you will do alcohol, when I am doing this alcohol dot drop Na, what I am actually doing, there is one parameter inside this, and that parameter is called in place. So in place, if I will put in place is equal to false. Fine. If I will make this in place is equal to false, and if I will run this, and then if you, let's say, if you access this alcohol series, what you are getting? You are still getting NaN values. That means when this in place is equal to false, when this parameter in place is equal to false, then there is a changes in this alcohol series data, and that changes is that NaN values is I'm getting the NaN values in my output, but it is not permanently getting changed. So it means by default, this in place parameter is false. That's why I'm getting this. So what I need to do, I need to make it true. True means I want to make the permanent changes in my data set, in my data. So if you will make this parameter true, let's make it true. And then if you will run this, and now if you will check alcohol, can you see? Now there is a changes. Because this time what you have done, you have, instead of using this in place is equal to false, I am using this in place is equal to true. When I am using this in place parameter, when I am giving this parameter the value true in place, then there is a permanent changes in my alcohol series. So one way is either you can do reassignment. Another way is using the drop Na method. alcohol dot drop NA printed, you have to make this in place parameter true. So this is one. Now, after that, what I have written here at the beginning, dropping and filling NAs. So one way is that you can drop the NAs. Another way that you can fill that NA values with some other values. Let's say, so if I will, since I have made changes, so this alcohol data, this changes has been permanent, so I cannot reverse it. So for doing the same thing, I have to rerun this cell. So let's, instead of rerunning, let me do this again. Let me create this data, uh, this alcohol series again. That would be a good idea. So I'm creating it again because I want to perform this. And let's do this. Let's do this. Fine. Let's do this. Fine. Now, if I will access it again, I am getting the same thing. Now, let's see. Now, in this alcohol series data, I want to fill all the NaN values with some other values. Fine. So what I will to do? For that you have to write alcohol dot this method called fill NA. Fill NA means fill all the NaN values. And let's say I'm writing 100 here. So if you will see here, Afghanistan is having NaN values and this Yemen is having NaN values. After doing this Afghanistan and Yemen will get filled with 100. And this time, let's say I'm making this in place parameter to be false because I do not want to make the permanent changes, let's say false. So what will happen? Let's see. Can you see? Here, Afghanistan is having NaN and now this Afghanistan is having 100 because I asked it to fill this with some value. So whatever value you will pass here, it will get, all the NaN values will get filled with that value. Is it okay? And since this in place parameter is false, so this is not a permanent change. So if I will access my alcohol data again, series again, I will get the original value. Fine. So this is all. Now let's come to a next topic that is called descriptive statistics. Descriptive statistics. Statistics. There will be a lot of concepts inside this, but I'm not going to explain you in very details all of those concepts because these are actually the part of a statistics. And whenever I will be covering the statistics, at that point of time, I will be explaining you all those things. But yes, I will give you a decent idea about these things. Fine. Let's start. Oh, dear. Fine. See, let's try to understand this descriptive statistics with the help of the alcohol data only. So if you will access this alcohol data, what I am getting? These things. Fine. I want to calculate, let's say, I want to calculate the sum of all the values inside this. So one very simple way to calculate the sum of all the values inside this alcohol series is like you have to do alcohol dot sum. Simple. If you will do this, you will get the sum 8221.0. Now, to calculate the average, or you can say mean values of those things, what is the way to calculate the average, or you can say mean? To calculate the average or mean, we need sum of the quantity by number of the quantity, or sum of the observations by total number of the observations. This is all. So what I need to sum all these things, and then I need to divide it by the total number. And what is my total number? 193, I know. So let's do it by like this. Let's calculate average. Average, to calculate the average, what I need count. So we have to write alcohol dot sum. So this sum will give me the sum of all these values, and divided by alcohol dot count, count. If I will write this, so I will get the count of all those values. So sum divided by count will give me the average. So now if I will run this, I will get the average. And the average is 50.7469. This is my average. You can calculate the average by this. And you can also calculate the average by using this method .mean, mean. If you will simply do alcohol dot mean, you will get the average. And you can check both is same. This is a general, to calculate the average of anything, we use this like formula or this mathematics. And here you are directly getting the mean by using dot mean. Now, there's another thing called median. What is median? Median is basically the mean value, so middle values, not mean values, is basically the middle values. So for calculating the median, you have to simply write alcohol dot median. Let's say if you will do alcohol dot median, you will get the median values, the middle values. Fine. After that, there comes a concept of quantiles. So you can also calculate the median with the help of quantile. So how? Let me write it first. Alcohol dot quantile. And you have to set the value of quantile is equal to 50%. If we will set the quantile 0.50 or 50%, you will get the median. Can you see? My median is here 11.5. And when I am calculating my quantile and setting the value of quantile as 50%, then also I am getting the median. What I mean to say, you have to ordering our data and then looking at quantile 50, quantile 50 gives median. So ordering our data, first we have to order the data and then we will look at the 50% quantile. This will give me the median. Now this is fine. But many of you must be wondering what this quantile is and what is this. So these are the things that I am going to discuss in statistics, but let me give you a little bit idea. See, in statistics and in probability, a quantile is a value that divides a set of value or a probability distribution into a specific number of equal sized groups. So let me write it here. A quantile, a quantile is a value that divides a set of data or a probability distribution into a specific number of equal sized groups. Fine. So let me explain you this quantile thing in a so that you will get a hang of it. See, imagine that there are some numbers, let's say 10, 20, 30, 40, 50. Let's say there are some numbers and I have arranged it from smallest to largest in increasing order. And let's say if I want to divide these numbers, so how many groups will be there? I have to make this cut. This is one cut. This is one cut. And this is one cut. So number is 1, 2, 3, 4, 5. There are 5 numbers, but how many cuts it is making? 1, 2, 3, 4. If I will divide it equally, let's say if I want to divide these 5 numbers into equal spaces, so how much spaces will be there? There will be 4 spaces. 1, 2, 1, 2, 3, and 4. Okay. Because I want to, let's say, separate these things. So these cuts are called basically, these separations are called basically quantiles. They mark the boundaries between each group, ensuring that each group has roughly the same number of data points. So now, the qth quartile, qth, let's say qth quantile, or you can say quantile of some data set or distribution is the value such that at least Q% of the data, qth percentile means qth percent of the data, that is qth percent of the data points are less than or equal to it. And 100 minus Q percent, 100 minus Q percent of the data points are greater than or equal to it. So this median is basically means 50th percentile. 50th percentile. That means 50% of the data points are below it, and 50 points of or you can say 100 minus 50, that is the 100 minus 50, if you will say, that is also 50. So 50% of the data is below it and 50% of the data is above it. It divides the data into two equal halves with 50% of the data points below it and 50% of the data points above it. Fine. So this is all about the quantiles. So you must be getting a hang of this quantile. Let me erase this and come to our discussion. So have you understand this median and this quantile? Fine. Now there is something called, let's say if I want to if I so there is something called histogram. So for creating a histogram, we have to of the data. Let's say we have a series data. So there is a way called alcohol.his. If I will simply write, if I will simply do this, see what I'm getting. I'm getting this graph and this is called histogram. So how this is called histogram, and how this histogram is like, here 0 to 50 is there, sorry, 0 to 100, and here 0 to 350. So from 0 to 50, in this range, the maximum value is there, and thereafter it is decreasing. Can you see? This is called the histogram. And this histogram is created with the help of this alcohol series data. So if you will see in this histogram, so the values which are in this range is having the maximum values, and then it is decreasing, decreasing, decreasing. Here it is decreasing here, and here in this side the values is basically reduces to. So it is almost, if you will draw a graph, it will you will see that it is somewhat a skewed distribution is there. Here you can see a skewed distribution is there. That means uh, we will discuss those things, skewed in skewed and right skewed, left skewed in the statistics. But if let's say I will draw this thing, let's say if I will draw some graph here, I will get a skewed distribution. If there is there is a distribution called Gaussian distribution, it is something like this. So in both sides, the distribution is equal. But if you will look at this, it is this distribution is skewed towards left. This is skewed towards left. So this is how, and this is not a Gaussian distribution. Gaussian distributions look something like this. We will discuss this Gaussian distribution and all those things later. Fine. Let's move ahead. So there's one thing called IQR. IQR. This is called interquartile range. It is also called interquartile range. Interquartile quartile range. Interquartile range. So how this IQR works? To calculate IQR or interquartile range, what I have to write? I have to write alcohol, then dot quantile, 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 and then you have to pass, because interquartile range is a difference between the 75 percentile and the 25 percentile. So you have to write this alcohol dot quantile, quantile, and then this 0.25, 0.25. This will give me interquartile range. If I will access this IQR, what I am getting? I will get this 58.25. This interquartile range. After this interquartile range, there is one concept of minima and maxima. Yes, I got your point. Varun, I got your point. So minima and maxima. Minimum and maximum. So what is this minimum? How to calculate the minimum and maximum? Alcohol. If you will write alcohol dot minimum, you will get the minimum values. Let's do it. You will get this minimum values 1. And if you will write alcohol dot max, you will get maximum values. So here I am getting the maximum values as 339 and minimum values as 1.0. One thing is called standard deviation. A simple definition of standard deviation is how far the distributions is away from the mean. That is called standard deviation. So this standard deviation, to calculate this standard deviation, what you have to do? You have to simply write alcohol dot st. If you will simply write alcohol dot std, you will get a standard deviation. So this is the standard deviation. Similarly, there is one concept called variance. If you want to calculate variance, V-A-R-I-A-N-C, variance, what you have to do? You have to write alcohol dot VAR there. This will give me the variance. Fine. Here I am getting the variance as this. And this is from my knowledge. I know that the square of the standard deviation is equal to my variance. So you can check this also. What I have said, square of standard deviation is equal to my variance. So if you will do alcohol dot std, standard deviation, and if you will square it, that means if you will raise to the power 2, if you will raise it to the power 2, and you will check, is this equal to alcohol dot VAR? That means variance. You will get true here. Because this means this is true, that standard deviation square is equal to variance. Now, these are fine. So one by one, what I have done in the descriptive statistics, I have taken this series, alcohol series, and I have calculated sum, then mean, then median, then histogram, interquartile range, minima, maximum, standard deviation, variance. All these things I have calculated. Fine. But there is one very simple method to do all those things. You do not have to do when you will be doing the descriptive analysis, descriptive statistics of any data when you want to find. So there is one very simple method called the describe method. This is called the describe method. And how this describe method works? Very simple. Simply what you have to do, you have to simply write alcohol dot describe. If you will simply write this, and if you will run, see what you are getting. In only one method, this describe method will give you everything. This count, this mean, standard deviation, minimum values. This is 25th percentile, 50th percentile, 75th percentile. This is not percentage, this is percentile. And this maximum values, all those descriptions you will get. So just by using this alcohol.describe method, you will get to know a very good idea about the data set. So how many number of counts is there? What is the minimum value? What is the maximum value? What is mean, stand, everything. So, and I would definitely recommend you to do this early on before you dive into analyzing the series data, because it gives the really good numerical sense of what we are working with. You can, and here you can also change the percentile according to your requirement. Usually we don't change it, but you can change it if you need. Let's say if I will write alcohol dot describe dot describe, and let's say I want percentile. Let's write percentile. If let's say I want these two percentile, 0.79 comma 0.19, let's suppose. And thereafter, let's say if I want to do comma include is one parameter, I want to include float, so let's write float here. And exclude object, let's say right, exclude is equal to object. This is also one parameter. If I will do this and if I will run this, can you see, instead of this everything is saying, only instead of this 25th percentile and 75th percentiles, I am getting this 90th percentile and 79th percentile which I have given here. Fine. Now, and if you will see earlier, if you will see this alcohol dot d type, let's see what you are getting. You are getting the data type as float 64 because here I have changed the data type, include is equal to float. Earlier this I know this is not a float because this is my series data. Alcohol is my series data. But since I have changed here, I have used this parameter include and I've used float here. So it has changed it into a floating values. And this time the data set D type is float. I am getting this D type float. Similarly, one last thing that I would like to discuss, let's say, is called mode. What is mode? Mode and value counts. So this mode, let me write here, mode and value counts. Mode and value underscore counts. So what this mode and value count? Mode is basically the frequency at which any data has occurred inside a series. That is basically a mode. So if you want to check the mode, what you will get? Let's check here. Alcohol dot, if you will do mode, what you will get? 0, 1.1. Fine. This is my mode. And let's say if you will check alcohol is equal to 1, what you will get? So what you are getting, wherever the values inside this series is 1, you will get true there only. Rest thing you will get false. And length you are getting 193. Fine. And let's say if you will do this thing, alcohol, and inside this alcohol, let's write alcohol again. And let me write alcohol is equal to 1. I'm passing this thing only. Inside this alcohol, if I will pass this thing. So, and then I will check the size. What I will get? I will get 28. That means there are 28 values inside it, which is having a true value. That's why I'm getting the total number as size as 28. Now then, what is this value counts? So let's see value counts. If I will do alcohol dot value underscore counts, what I will get? I will get this thing. That means each one of the values, how many times each one of these values has occurred inside my series data, I am getting this. That means this one value has occurred 28 times. This two value has occurred 10 times. Likewise, this 185 values has occurred one time. So I am getting this. And you have confirmed here from also this size alcohol. I've used some different way to actually get the same thing. Get the same thing. To get the same value count. Here I've used this way because I to get the value counts. And here you can see there is a simple method. There is called value count. With the help of this value count, you will get all the number of values of that particular, the number of counts of that particular value you will get. Fine. And if you will do, so let's discuss it and then I will close it up. Let's discuss. It will take 1 minute more. So this is something because this is about the value counts only. If I will write alcohol dot value counts, and let's say if I will write normalize is equal to true, then what will happen? So this will basically what it will give me. This will give, this is not absolute value, but a relative frequency, relative frequency. So if let's say if you will do this, you will get, this is basically, what is the difference between this? This is a absolute value and this is a relative frequency. So what is this relative frequency? This relative frequency is like, if you will take, let's say if I am taking this 28, this absolute value, this 28, and then divide it by alcohol dot count. This will give me a relative value. Oh, sorry. Alcohol dot count. Can you see? 0.17239. So when I am dividing this entire thing with the help of this total count, alcohol dot count, I will get the relative count or relative frequency. This is not absolute but a relative, and you will get to know these things where because in the coming time in the machine learning, we are going to use this normalized concept very much, and there is a concept of normalization that we will discuss later. So there you will find the application of these things. Fine. So this is all, I suppose, and this is all for the day. There are a few more things, but I will discuss it next time during the next session. So let's, today is day 10th. So we have, let's commit the code. We have completed 10 days of Pandas series. Fine, let's first save this. Fine. Then commit it. Yes. Sync changes. Okay. So guys, so very soon I'm going to complete this series, and then we will be moving towards the data frame, and slowly and progressively we will keep learning these things. Fine. And those of you who are watching the recorded session and you guys are having any doubts, you want any specific clarity, you must put it in the comment section. And if you want to join my live session, absolutely free of cost. You can go to the description section of the video and join and subscribe my Telegram channel from there. And you can also join the Telegram group. I used to put the joining link there itself, and you will get the joining link from there, and you can join the session. Thanks for coming. Keep learning, keep enjoying. Bye.